Dean and Gavin, for those of you guys just joining us. They're working in groups currently on this example on the board. I told them they have 3 different tests to try. They should start with the nth term test. Does it tell us anything? Then go to geoseries. Can I use that test? And if worst comes to worst, integral test. Is it legal? And then go ahead and perform that test. They've been working for about 5 minutes. If you guys want to pause the video and work on your own, you may. We're going to start covering this in just a second before going to grade our section 9.2, the other textbook from Google Classroom, which you can be accessing the odds on CalcChat for and cover any questions they might have had. But for right now, let's go ahead and check in with them and see how they're doing. Sorry about my voice. Hopefully you guys can follow them.
What I have is just
What happened? What happened when you tried the nth term test? The limit?
you know nothing.
So, does that test work? No. Geoseries. What happened when you tried?
There's no
There's a pattern. Is there a multiplication? Now, could I make this ln of 4 and ln of 27 and ln of 128? Nope. 256. Yes. Could I?
Yeah.
Yeah, I can make them powers, but even then, is it a geoseries?
No.
No. So it's not a geoseries. It fails, and forget that, right? So it fails the nth term. I know nothing. It fails the geo, so what are we hoping we can use?
Integral.
The integral test, what has to be true first?
Continuous, positive, and decreasing.
So we're considering, remember, we have to think about the function. What's the function that this would be turned into? Let's analyze it. Is that continuous? No, but on its interval. Or x greater than or equal to 2, yes, right? We're starting at 2. That's why we didn't start at 1. At 1, ln of 1 is 0. That would be discontinuous. So it's 0. Good. Is it positive?
Yes.
Is ln always positive? No. But what is ln positive after?
2.
Well, for 1 and above, but yeah. For 1 and above, yeah, which means 2 and above. So yeah, ln is positive. For x greater than or equal to 2. Is ln increasing? Is ln increasing? So since ln is increasing, ln of 4, ln of 9, ln of 256, sorry, ln of 27, ln of 256. Question, what's going to be happening to these terms? Getting smaller, good. Because the denominator is going to keep increasing, which means the whole thing is going to be decreasing. Good so far? Okay. But do you see the possibility of a presence of ln maybe having a negative for a little bit before turning positive? Or the presence of an ln? Well, ln's are strictly increasing, so maybe that's not too bad. So what are we allowed to apply? Okay. So since we're allowed to apply the integral test, let's go looking at the integral from 2 to infinity of my 1 over x ln of x. And this is hopefully what you guys have been working on for the last few minutes. So what have we come up with? ln. How'd you get that? I think Lorenzo's thinking u sub. Were you guys thinking u sub? Because isn't du the 1 over x part? So the 1 over x dx can be du. ln is 1 over u. Oh, this is really just going to be the antiderivative of 1 over u, which is ln of, who's u? Absolute value of ln of x. From 2 to b, oh, that's right. Are you guys still writing, are you still writing your proper notation? Are you still doing your proper integrals the right way? Equals what? constant? I don't know. Infinity. Is infinity minus a constant? Who wins? So what am I going to make as my conclusion? Since the integral test applies, we have to make sure it can apply first, right? Could the nth term test apply? No. Could the geoseries test apply? No. So the integral test was a yes. And what else? Good. The integral from 2 to what ended up happening? Then series. How are we doing? We love the integral test. If the integral is easy, but even more so possible to find, because it'll tell us everything, but only if it's allowed to apply. It'll tell us convergent, convergent, or it'll tell us divergent, divergent, and we're done. Now wait, Lorenzo, you asked a really good question yesterday. I think it was at the end of class, maybe where people couldn't hear it. Lorenzo asked, okay, for the one yesterday that was convergent, I mean divergent doesn't really make a big difference, but convergent, he asked, can we figure out what it converges to? Can we figure out what it converges to? It was a great question. At this point, your answer should be what? No, because the only one that we know how to figure out what it converges to is what type of series. And geometric, if it's convergent, we know there's a formula we can plug into, and what would that formula be? But if I was to ask you for not whether it converges or diverges, but for the sum, right now, the only thing you'll be able to do is, well, it better be a geoseries, or I'm going to say it's impossible. I'll describe it for you. I'll describe it as convergent or divergent, but I can't tell you what it is unless it's geo for right now. And to be honest, by the end of the chapter, you're going to be able to say, unless it's geo or telescoping. Telescope. Not like a telescope as in up in the sky. I want you to think of like a pirate. What it's actually called. Is it a telescope? The one that like you pull out and they're like, right? And then they're like, I guess. Yeah, I thought they would call it like a glass or something instead. But I don't know. Eyeglass? Well, that's probably the Luminopoly. We're gonna come back. Hey. We're gonna come back to the integral test and the B-series test as soon as we talk about section 9.2. Now, John's question was great. You heard it. He said, "Do we need to grade or do corrections anymore?" Why do you think that? Were there any evens last night? Nope. So when I go to my answer key, I say no evens. Now, hold on. Look at section 9.3. Are there evens? Okay. Not the whole chapter. But just because there aren't evens, does that mean we have no questions? But it does mean we could have graded answers in the back of the book. No. Unless you came in here and borrowed my nifty book, which is, right here. But you could have gone on CalcChat and found the black one and then been able to check your answers in the back of the book. Right? Because I don't think, did I put answers in the back of the book in your guys' homeworks? No, but I think I did for, is it homework 40? Is that the next one? I put in something.
For 39 you did, but I mean on 38 it just says attempt and then 38.
Oh, I gave you all the evens? You have a link to my document, so when there are evens, you're going to be able to see it. I'm letting you see everything to grade for the whole chapter. Why? So you can do corrections at home and we can spend time in class on actually grading. Does that make sense? Sorry, homework number 39 is the one that's due on Friday. Why is homework number 40 up there? What's homework number 40? Hold on. Homework number 40 should not be up yet because we're having our quiz. That was my bad. We're having our quiz on 9.1 to 9.3 on Friday, so I'm going to, can I take this one down? How do I take it down? Can I unsubmit it? Can I hide it? Oh, there's no due date. Ignore homework number 40 for now. Sorry, guys. 39 is the next one that you're working on. But I gave you the evens to grades so that you guys can come informed to class when that homework is due, which right now it's due. Homework number 39 is tomorrow or Friday. Friday. I must be giving you guys a couple days to work on it, but be careful. We have that quiz. We're going to start studying for our quiz tomorrow. So the more you do tonight, the better. I'm just giving you a little bit of grace as to when you finish. Does that sound good? Okay. So let's go ahead and go back to last night's homework, section 9.2. Is there anything of the odds of those of you that were able to check, or if you weren't able to check, we'll lean on those who were that you want to ask about? Janelle? 53. Ooh, I hear a resounding yes. Look at that. That's a nice one. I'm grabbing a picture of it, but I'm listening if anyone else has something they want to hear or see. Call it out. Call it out. Anything else? Oh, look, I have it ready. Nobody needs 51. I have a copy of it. No? Just 53. Oh, we did?
Some of us.
Oh, because we were talking about e to the power. Okay, as long as you're fine. Okay, 53. We'll do a last call for questions. Because of D, we haven't. That's okay. Why not? Wait a minute. What are the 3 tests we're allowed to use?
Nth term, series, and integral.
Okay, so we have NGI, nth term, geometric, and integral test, right? National Geographic Institute. Sure, why not? NGI. So nth term, geo, integral test. Nth term says take the limit as n goes to infinity of the sequence, not series. So the limit as n goes to infinity, we're testing the nth term of arctan. Who is arctan? Who is arctan? Who is arctan? Tangent inverse. So we're thinking of tangent inverse. Tangent inverse.
We're too far to count.
Yeah, you're gonna. Which is this guy, right? Does he go to infinity like every other, like a cubed root function? No. He has vertical asymptotes that flipped when he did, right? He was a tangent and then he flipped and his vertical asymptotes flipped too. So, as I go to infinity, now here's your proper question. What's the limit of arctan as n goes to infinity? Which is not 0. Does this test apply? Yes. So therefore I can say, haha, by the nth term test. Series. Yeah. Careful. Since the sequence converges to a constant that is not 0, since the limit of the sequence is anything but 0, divergent done. Is that good? But even if it was infinity, still not 0. So even if you weren't sure, it's still not 0. You could just say not equal to 0. Okay. But pi over 2 is important to know for the AP because tangent just gets closer to his vertical aspect. Yeah, like regular tangents where they flipped when tangent inverse flips. Okay, we're good on 53 alone. 51 is a special converging sequence. We would have had to see that. How do you take a limit as n goes to infinity when it's in the wait? Okay. Any constant. Like an x. Okay, is any constant like an x. Okay. N is the guy that I'm focused on. Wait a minute. This would be 1 plus bottom wins because that's just some constant, some number, and he's ever increasing. That's just like a set number that's increasing. So I have 1 plus 0. What's 1 to the infinity? 4. But if you remember the special converging sequences, this would be an e to the k. And question, can e to the k ever be 0?
No.
How do you know? Are you visualizing the basic graph? Now it always approaches 0, but will never become 0. Okay, good. So then therefore, not 0. So what do I know? Of the sequence, it does, but it doesn't equal 0. So nth term test, remember, when the sequence, I know it's hard, but when the sequence converges to any constant not 0, or diverges to infinity or negative infinity, all of those, if not 0, divergent. The series is divergent. Because, think of it this way. Just for some of you, you're just now starting to grapple with some of the concepts I addressed earlier on. If I was to give you something like, sorry, my voice is dying. We could just do something basic like, if we were to plug in 2 times 1 over 1 plus 1 is 2. 2 times 2 over 2 plus 1 is 3. 6 over 4, right? And we could keep on doing 8 over 5. And then we could do 10 over 6. Okay. Are these terms of the sequence, of the sequence, are the terms increasing? Yes. Are the terms bounded? Are the terms bounded? Is the sequence bounded? What will these terms never go past? 2. Because the limit as n goes to infinity of the sequence is degrees are tied 2 over 1. These terms are going to keep on getting closer and closer and closer and closer and closer and closer to 2. The terms are bounded. Does that make sense? The terms are converging. But what's happening to each of the terms? No. They're being added. And so what's happening to the partial sums? At first, you just have s sub 1 is just 1. S sub 2 is 1 plus 1 and a third, 2 and a third, right? S sub 3 says now I'm adding an extra guy. So I have 1 plus 1 and a third plus 1 and a half. So I have 3 and, what did I have, a third and a half? Will end up being 5/6. No, that was way too big of a jump. A third plus a half, 3, 4/6, which would be 2/3. No. What's a third plus a half? 2/6 is 5/6. I was right. Sorry. 5/6. That's S sub 3. When we do convergence of series, we're not looking at terms, even though they can be helpful to tell us what's going on. We're looking at the sums. What happens when you add and add and add? Even though the terms are getting closer and closer and closer to 2, what am I going to be doing every single time with the sums? Adding 1 and something, right? 1 and a half, 1 and a third, 1 and a half, 1 and 3/5, 1 and 2/3, 1 and, I'm going to keep on adding 1. And what's going to happen if I keep on adding 1 and something? Divergent. Exactly. So anytime the limit of the sequence equals anything but 0, I'm going to be ever expanding as I add. Does that make sense? Even though they're bounded, I'm still ever expanding the sum. And And so therefore the sum is going to be divergent. Now, when the limit equals 0, it's confusing because the terms are getting smaller and smaller. But you're adding, but they're adding less and less. Is it converging? Is it not? Sometimes yes, sometimes no, like we've already seen. If we do this guy, I guess I should do n, sorry, of 1 over n squared. Both positive, both continuous for x greater than or equal to 1. Both decreasing. As I go, the terms are going to get smaller because the denominator is getting bigger. Both meet the conditions for the integral test. The improper integral of this guy will lead me to a 1 over x from 1 to b as b goes to infinity with a negative. Thank you, Lorenzo. And when I plug in the b going to infinity, I'm going to end up with 0 minus a negative. The integral converges, which means the series converges to 1? No, not to 1, but to something. Not to 1, but to something. But over here, what happens when I do the integral test? Sorry, B. What was the limit of a sub n? 0. What was the limit of a sub n? 0. One of them diverges, one of them converges. If the limit is 0, I don't know. I need something else to show me. It gets really, really confusing because they're both getting smaller and smaller as you're adding, but this one's going to go to an infinite amount. This one's going to be bounded by another amount. Confusing. But if the limit equals 0, we know nothing. If the limit equals anything but 0, we are for sure it's going to be divergent. Anyway, guys, I know it's confusing. I figured since you were thinking through a lot of these things in homework, that might help the majority of the class with an understanding of why we have to be so careful with the tests. Kevin.
How do you series apply in real life?
I think in higher proofs. The majority of the applications are found. But to be honest, I haven't applied series in so long. I don't remember how or where we did in college. But Joe, did you look it up?
No, I was gonna ask. Then why didn't the College Board put such a big emphasis on it? Or
why does every college in America for Calc Level 2? Why is the majority of its sequences in series? You're asking me, a high school math teacher, to explain how or where a certain branch of math is applied in real life. It's okay for me to say I'm not sure, but I would love for you guys to research it and come back. Like I teach random things, like I teach matrices in pre-cal. I never went into computer programming. I had kids come back who are computer programmers. I have a mission controller at NASA right now. Anyway, they say through their computer classes, oh hey, linear algebra, matrices are actually really important in programming. Like, who would have known? I didn't know, but I had kids go learn and come back and tell me. Sequences in series, to be honest, I don't know. But when you go to college, ask your professor, but I'm sure if you search it now, and maybe I should too, but sadly a teacher's list, I have so many things I still need to check off for today, let alone this week, let alone this month. If you would like to research it, I would love to. Yeah, but great question. It is, right? But if every college in America is teaching a calculus level 2 class for engineers and for computer programmers and for mathematicians, applied and pure, there has to be a purpose to it. I just don't really know. I do know that Calc level 3, which you guys aren't even going to really see from me with double and triple integrals, it kind of seems like what was the point of convergence and divergence. In that Calc 1 and Calc 3 are very similar. Calc 2 is this kind of little odd man out, like why is he there? So you're not the only ones to ask this question. I just, to be honest, haven't had people really push me on it the last few years. They were kind of like, whatever, it's a thing. Colleges need it. Okay, you guys know last year's class. Colleges need it. Like they were just, well, besides not doing their homework, but they just kind of took me at face value. So yeah, go ahead and research it. Come back. I would love to know. We're here integral, and I'm just pleading ignorance on the rest. Integral and p-series test. We did integral test yesterday. And we did all the examples, including the one in the back of our homework spiral this morning, but one. But come on. after that 1 over x ln of x over that 1 over n ln of n, you guys should be able to look at this and know exactly how we're going to solve this integral as long as the integral test applies. But how are we going to solve this integral if we do it? U sub, because this is u. Who's the u? We have to test to make sure really quickly that it works. Oh, you gotta be kidding me. Wait a minute. I'm really thinking about tangent inverse values. Okay. Do we know tangent inverse of 1? Pi over 4, right? Over 1 squared plus 1 is 2. Do we know tangent inverse of 2? No. But what do we know about tangent inverse, even though we don't know tangent inverse of 2? It's going up, but at slower and slower and slower increments, right? And what is it going up towards? And what is pi over 2 approximately? Right? Wait a minute. Didn't the denominator go up by 3? If tangent inverse, pi over 4, went up by 1, and it's bounded by 1.5, who's getting bigger faster? The bottom. So what's happening to the number? Decreasing. And is it positive? Yeah, because all these tangent inverse values are positive. So anything for n greater than or equal to 1 is positive. So I have, okay, we're considering the function. Sorry, my bad. We're considering tangent inverse of x all over x squared plus 1. Joe and Kevin, I just don't want to leave it at that because that's kind of a lame answer. Let me text my kid who's in grad school at UCI and be like, hey, sequences and series today come up. Because she was like a applied math major at Cal Poly SLO through the honors program there. And now she's getting her PhD in pure math because she likes it better. Let me just see. I'll see what she says. We can also research it too. Tangent inverse of x all over x squared plus 1. We have positive, yes, on this interval. We have continuous, yes, on this interval. And we have decreasing, yes. I don't know tangent inverse values, but I can show conclusively, or I can at least know conclusively. Those 3 things are true. I'm good. So now what can I say? Isn't this u du? U du? Isn't this u du? Why not just go 1 half u squared? Who is u? Got it. What's true? Yeah. Why does it converge? Because it's a constant. What constant is it? Something kind of gross because I'm going to have going to infinity. That's going to be pi over 2. Pi over 2 squared is pi squared over 4 minus. And then I'm going to have tangent inverse of 1, which is pi over 4 squared, which is pi squared over 16. But either way, I don't know that it converges to this, but since the improper integral converges, what can I say by the integral test? How are we doing on the integral test? Good. Let's go see that second guy. I didn't like the way that the test wrote it, so I wrote it a different way. The second half of section 9.3. The second half of section 9.3. Nice thing is that most schoolers are done by now. Even though we're not going to get tons of practice in on this P-series test, it's actually a really easy one. It only applies to very, very special functions. It's actually an easy one that only applies to very special functions. It only applies to ones of the form, or that can be written in the form, of 1 over n to the p. What if we had 2 over n to the p? Does this test fail? Nope, because we can pull out a 2. What if we have 10 over n to the p? Does this test fail? Nope, because we can pull out a 10. What if we have 1 over n to the p plus 1? Does this test fail? Yes, because I cannot rewrite that. But the nice thing is about this test is that this test tells me I can know the convergence and divergence of a series just based on the power. It's very similar to the improper integral in Deborah card that had to do with the improper integral of 1 over x to the p. Very similar. Why aren't you allowed to use 0 with this card? If you had a series where I had 1 over n to the 0, isn't anything to the 0 just, and isn't 1 over 1 just an nth term fail? That'd be an nth term fail, nth term test. Diverge. I don't need the p-series test. And what if p is less than 0? Well, if p is less than 0, then hold on. Doesn't it not even belong in the denominator? If p is less than 0, then technically it's a negative number, which means technically it really is just a funny way of saying, this gets awkward now. It would actually end up flipping to the numerator as a positive, and with the negative, it would be a positive. It would actually be, once again, an nth term test fail because the limit would not be 0. So these two are actually nth term tests, but everybody else is this one, and check it. It's super nice because, once again, if it applies, it can tell me divergence or it can tell me convergence. It's not like the nth term I can only do one thing. It's like the integral test, I can do 2 things, but it only works for very special cases. So the nice thing is, guys, if I was to go back to what I showed with the integral test just a moment ago, how we were trying to consider the infinite series of 1 over n squared versus the simple harmonic series of 1 over n. Hey, springs bouncing, simple harmonic motion. Coming back. What could we say now by p series? Since p equals 2, which is greater than 1, I can say by p series, this guy converges. What about this guy? Since p equals 1, which is not greater than 1, I can say by p series. You see it? I just made it up. I got it. I don't think there's a sign. But not equal to 1. I took some creative license. I see you guys later.
You said, oh, I'm done.
That's not the question.